Welcome pre-cal students to class today on this Thursday, the 21st of November. Hope you guys are doing well. Hope you're ready to learn some math today. A couple of you guys have come over and got some help this week, so always try to take advantage of that when you need to. Let's quickly look at some announcements here. We have a test on Monday. If you're not going to make it, please let me know by Sunday. I would appreciate it no later than Sunday. Your integrity sheets are due when you walk in the door Monday. Now you're welcome to go home and watch videos and do homework, but you will not get credit for those. So be honest, turn those in. You must have a sheet of paper with everything written down. Please turn those in Monday when you come to class. Monday will be our last day of class until the following Monday. Let me explain why. I don't want your parents to think that you're missing a whole other week of school like fall break. We were going to have a video on Tuesday and Wednesday and then take off for Thanksgiving break Thursday and Friday. And I'll be honest with you, we've done quizzes on Saturdays for at least 6 quizzes, and most schools are going to take Wednesday off or go half a day. And so we're just going to go ahead and say we'll take these 2 days off. We're doing great. Again, we have at least 6 days to work with because we've done 6 Saturdays on our quizzes. So we're doing totally fine. So after you take your test on Monday or after you come to my house on Monday, you will not have to watch another video until the following Monday. Now here's what we're going to do today. We're going to look at some word problems, okay? And we're going to look at word problems involving vectors. And we're going to work these together. There's 10 problems. Instead of me giving you notes and homework on top of that, I'm going to give you 10 problems and we're going to do them together right now, and you're going to learn as you do the homework. Now at the end of the class period, I will give you the review sheet that's due on Monday if you want the 5 bonus points. Now listen, if you want the 5 bonus points when you walk in the door Monday, you will have tried every single problem, okay, and mark down where your questions are. So if you don't attempt every problem on the review sheet before you walk in the door Monday, then you'll not get the 5 bonus points. Now, if that's not a big deal to you, that's fine. That's totally up to you, okay? Your decision. So let's work through these 10 problems right here. Go ahead and turn your books to page 652. If you would like a heading today, I would call it Vector Word Problems. Vector word problems, and the lesson number is 7.5 if you'd like to keep track of that type of thing, which I encourage you to be organized. And the date today is the 21st, November 21st, 2013. Okay, so copy that down if you want to, and then copy this down. And after we do a couple, if you want to pause the video and try some of these on your own, then watch the video. That's totally up to you, okay? Your decision. So 13, 15, then 25 through 29 odd, and then 33 through 41 odd. All right, let's go ahead and get started. Let's take a look at number 13. 2 forces of 32 newtons and 45 newtons act on an object at right angles. Find the magnitude of the resultant and the angle that it makes with the smaller force. Now, I've worked these out ahead of time to save time, so give me a second here and let me find where I'm at in my notes. Okay, here's what the problem says. 2 forces act on an object at right angles. Now what that means is this. Please take some really good notes on this. That means we have a force going one direction and a force going another direction, and they act on this point right here at a right angle. Now one of these is 32 newtons and the other magnitude or length is 45 newtons. So do you see how I set that up? Let's look at it again. These 2 forces acted on an object at right angles. So right here's a right angle, okay? And it's pushing on this object. One has a force of 32 newtons and one 45, okay? And it says find the magnitude of the resultant. Now remember, the resultant means we're going to go ahead and draw like an imaginary rectangle or imaginary parallelogram here. In this case it'll be a rectangle, and then the resultant means we're looking for this line right here. Remember that? That's the vector we're looking for. Alright, so we're going to find that, and then it says find the angle that the resultant makes with the smaller force. So here's the resultant, and 32 is smaller than 45, so 32 is your smaller force. So we're going to find this angle right here a little later. Let's worry about that later, okay? Let's go ahead for now and let's find the length of this line right here. Now, I taught you the other day. Let's go ahead and get out our Sorry for drawing a blank. I apologize. My shape recognition here. Okay, this is 32 right here. Okay, as you guys can see. So that means this over here is also 32. And I'm trying to find this length right here. Now, what I'm going to do is I'm going to trace this triangle right here, and I'm going to pull it off to the side. Okay, so there we go. And let's see if we can't pull it off to the side. So there's a triangle, and we know this is 32 and this is 45. Now, why did I do that? Well, because I'm trying to find this length x, and I thought it would be easier if you guys could see that we have a triangle here. Now, what I taught you yesterday was it's in a parallelogram. Two angles side by side will always add up to 180. They're supplementary. So if this whole angle is 90 right here in the parallelogram, then this angle right here also has to be 90, because 90 plus 90 is 180. Now we can use the law of cosines, or I guess we can, come to think of it, I did use the law of cosines. We could have used, I'm going to go ahead and change. I'm going to use sine, cosine, and tangent. I mean, look, guys, I've got a right angle, right? So my goodness, let's just very quickly find the this length right here using Pythagorean theorem. So I'm going to have the square root of 45 squared plus 32 squared, and what I should get, let me look at my notes here, is 3049. And then if you take the square root of that, you will get 55. Now I'm not sure if I rounded or that's exact, but there we go. So because I had a right triangle, I did not need to use the law of sines. I did not need to use the law of cosines. All that I had to use was Pythagorean theorem. So now I know the length of x is 55, so you just found the resultant. Good job. This length right here is 55, which is this length right here. So you just found the resultant. Now they're going to ask us to do something else. Now they want us to find the measure of the angle that's formed with the resultant. So here's the resultant, and the smaller force, which is this right here. So this angle right here. All right. Now I'll be honest with you. Really, it should be pretty easy to find that angle. I mean, here's your triangle right here, guys. Look, here's your triangle you can use. You can use that triangle right there. And if this is 45 right here, then this is 45 right here. And this is going to be 90 degrees. So to find this angle x right here, think about it. I'm looking for this angle here, right? So based on this angle, look, I've got a right triangle, so I can use sine, cosine, and tangent. Based on this angle, I have an opposite side, and I have an adjacent side. Well, that's tangent. So tangent of angle x equals opposite over adjacent. Opposite over adjacent. All right, and if you type that into your calculator, second tangent or inverse tangent of 45 over 32, you will get 55 degrees. 55 degrees. All right, so y equals 55 degrees. And I guess I called this x. I should have called it y because we already had an x over here, so I'm going to call that y. But either way, so that angle right there is 55 degrees. And there we are. Okay. All right, let this sink in, and let's go on to the next problem. Let's take a look at number 15. Number 15 reads, two forces of 410 newtons and 600 newtons act on an object. The angle between the forces is 47 degrees. Find the magnitude of the resultant and the angle that it makes with the larger force. Now, here we go, guys. Read it carefully. You have a force of 410 newtons and 600 newtons acting on an object. The angle between the forces is 47 degrees. So, that means I'm going to have a force. Let me change that very quickly. I'm going to have a vector go in this direction, and then one that comes off at about 47 degrees. Now, I don't care if they're drawn to scale. I don't care which one I call the bigger one and which one I call the smaller one. It's not a big deal to me. I'm going to call this one 410, and I'm going to call this one right here 600. Okay, there we go. And we know this is 47 degrees. Okay, 47 degrees. Now, they want us to find the resultant, which means I'm going to have to go ahead and draw my parallelogram here. So go ahead and draw your parallelogram. There we go. And they're asking us to find the resultant, which would be this line right here. So we got to look for that. We'll call that x. And then we'll worry about the angle thing later, okay? So let's go ahead and find this x. So what I'm going to do is I'm going to try to pull this triangle off to the side so we can see it a little better. Okay, so there's the triangle, and now I know this has a length of 600, and then if this right here is 410, then this side here has to be 410. And now remember, consecutive angles and a parallelogram are supplementary, so if this whole angle here is 47, then this angle right here has to be 133 degrees. 133, because 47 plus 133 is 180. So this angle right here would be 133 degrees. And now, of course, we're looking to find x. So we are going to use law of cosines, and I would say x squared equals 600 squared plus 410 squared minus 2 times 600 times 410 times cosine of 133. Alright, now I've already typed that in, and what you get out if you type it in correctly is going to be 929. So x squared equals 929. Alright, and now we take the square root of both sides, and if you take the square root of both sides, I'm sorry, that's incorrect, and I apologize, guys. X squared equals 863,643.1932, and then take the square root of both sides, and I'm sure I rounded this, you get 929. So there's the resultant. That's pretty simple. That's not hard. 929. So you found the resultant. Okay. Now next, they want us to find the measure of the angle that is formed with the resultant and the larger force. So here's the resultant right here, and here's the larger force, 600. So they'd like us to find this angle right here. We'll call it y. Well, that's this angle right here. We'll call it y. Okay? So let's go ahead and erase. Didn't mean to do that. Let's go ahead and erase all of this down here. And let's see if we can't find y, okay? Now, notice how we have a pair. We have this angle, and right across from us, 929. So students, we can use law of sines very quickly here. I mean, 929 over the sine of 133 equals, now we're looking for y, so I would say, and the side across from y is 410 degrees, so 410 over sine of y. Now if we cross multiply and divide, we're going to get sine of y equals 410 sine of 133, this times this, and then 929 times this, you'd have a 929 right here, but we're going to end up dividing both sides by 929 anyway, so it's going to be right over here. Alright, now if you type that into your calculator correctly, this right side of the equation, you will get out a decimal that says this. Let me look at my notes here. 0.4723. 0.4723. No, that is incorrect. I'm sorry. You guys are going to think I really didn't do these ahead of time, but I did. Let's see. 410 sine 133 equals, divided by 929. You'll get out 0.3227. Sorry about that. 0.3227. And then we're going to take the inverse sine of that to find the angle, and you're going to get 18.8. I'm going to round that to 19 degrees. So y equals 19 degrees. So this angle right here is 19 degrees. And there you go. That's the angle formed with the resultant and the larger angle. Not too bad. Next is number 25. Now, 25 sounds confusing, just like 27 does too, but they've given you the drawing. So with the drawing, all that you have to do is just find what you're missing. A hot air balloon is rising vertically 10 feet per second, while the wind is blowing horizontally at 5 feet per second. Find the speed v of the balloon and the angle theta that it makes with the horizontal. Okay, so they want us to find the speed v, which would be this line right here. It's labeled v for you in the diagram. So all that they want you to do is just find v, and look, it'd be Pythagorean theorem. You know you have a right triangle even though it's not marked, and here's how you know that. If you look at the problem, it says it's rising vertically and the wind is blowing horizontally. So vertically and horizontally form a right angle. So if you want to find this length of v right here, try to make this a little bigger so we can see it. There we go. And get rid of these things here, I guess. So if we're going to find v, let's just use Pythagorean's theorem. I mean, it'd be the square root of 5 squared plus 10 squared, which ends up being the square root of 125, which would end up being 11. So because this was feet per second and this was feet per second, then when we get out 11, we label that feet per second. All right. So there we found vector v, which basically what we found was, according to the problem here, we found the speed of the balloon. And now they want to know the angle that it makes with the horizontal, or this angle right here. Well, students, it's a right triangle. So let's just use sine, cosine, or tangent. Let's say tangent of theta equals opposite over hypotenuse. 10 over 5, which of course 10 over 5 is just 2. So tangent of what angle would give me 2? And if you type that into your calculator, second tangent or inverse tangent of 2, you will get out 63 degrees. Okay, so theta equals 63 degrees. So this right here would be 63 degrees. And we are moving on to number 27. Let me grab a quick drink of water here. And here we go. A boat has 35 degrees propelled by a force of 750 pounds. A wind from 320 degrees exerts a force of 150 pounds on the boat. How large is the resultant force F, excuse me for yawning, sorry, and in what direction is the boat moving? Now, first of all, let's start with the and you know what? Did I not have a picture for this? I could have sworn I did. Oh, I have two 27s. Okay. I thought I had a picture for that. Let me delete that slide out of there. There we go. Okay. So if you'll look here at the picture in the book, they've asked us to find the resultant F. Okay. And let me gather my notes here real quick. It really shouldn't be too hard to do because we have an angle right here. Let me highlight the triangle for you. We have this triangle right here, and I'm going to cut it out in a second. We have that triangle there. We have a side, then an angle, and then a side. So we can use the law of cosines on this. So I'm going to very quickly try to cut this triangle out if my drawing skills will allow me, which I don't have very good. I don't have very good ones, that's for sure. And let's pull this over here. Let's shrink this back up. And let's see what we got here. Okay, now according to the diagram here, we can see this is 150, and you see that right here, and this is 750. Now I know this looks like a right angle, but number one, I didn't draw it very good, and number two, if you don't know for sure, you just can't say that it's a right angle. And then we know this angle right here is 75 degrees, okay? So we can definitely use law of cosines. We can say this side right here, and by the way, this is F, side F right here. I'm going to go ahead and use F. So F squared equals 750 squared plus 150 squared minus 2 times 750 times 150 cosine of 75 degrees. Now, if you type that whole thing into your calculator, you're going to come up with F squared equals 526,765.7149. And if you take the square root of both sides, you will see the force is approximately 726. So now we know the force, or the resultant force F, is 726. This vector right here, the length or the magnitude, okay? Now they want us to find, now listen to this carefully, they want us to find what direction the boat is moving. Now, excuse me for yawning again, the boat, if you look at the very first sentence, it says the boat heads 35 degrees. So see this 35 degrees, that's the boat, the original path of the boat. So here's the boat. But then there's a wind affecting it, and so they're going to factor that into it. So let's find this angle theta right here, okay? So let's find this little angle right here, and I'm going to show you guys something when we do that, okay? Let's find that little angle. I think we can use law of sines, I believe. Let me look at my notes. Yeah, we have 700, this is 75 degrees here. And we know this length right here is 726. So 726 is across from 75 degrees, so I have 726 over the sine of 75 degrees equals, now I'm trying to find this angle here, and what side is across from that angle? 150. So 150 over sine of theta. Now if you cross multiply and divide, you're going to end up with sine of theta equals 150 sine 75 all over 726. And if you type that into your calculator correctly, the right side of the equation there, let me look at my notes, I'm getting out that you will get something like 0.1995. Okay? Now, if you then take inverse sine to find this angle of this decimal, you will see that theta equals 12 degrees. Now, think about that, please. If theta, this angle here, is 12 degrees, if this angle right here is 12 degrees, right here, well, the boat was already heading 35 degrees. We know now it's heading on this new resultant here. And so it's going to be 35 degrees plus 12 more degrees. So the new direction of the boat is 47 degrees. Not super easy to see, but not super hard either. So I hope that makes sense for you, okay? Now, let's continue on. Again, we're just taking word problems and working these for the same time. Excuse me, for the first time. Now, let's see if we do not have 29. And I'm not sure why I did not put 31 on here, but we need to do 31, I believe. Let me quickly rotate to the top here and check out the assignment that I gave you. I didn't include 31, did I? Let's see. Okay, let's see. The one that I wanted to skip was, if you'll look here at the assignment, I did not want to do 29. It's an amazingly difficult airplane word problem, and I wanted to stop at 27 and then do 29. I believe, let's see here. Sorry guys, I do apologize. I had all this written down. I'm not sure what happened. I wanted to do 25 and 27 and then skip 29. So 25, 27, and then do, I'm not making the assignment any larger, I'm just skipping a different, and then 31 to 41. So we did 25, we did 27. Now let's jump on to number 31. All right, so there's 27, and I'm going to squeeze 31 in here right now because I want 31 in here. Okay, here we go, number 31. A vector W has magnitude 100 and points southeast. Now we're doing something new we've never ever done before. Look at number 31, the last sentence. Resolve the vector into easterly and southerly components. Now, here's what we've done in the past. You've been given two vectors, okay, and you have found the resultant. But now I'm going to give you the resultant, and you're going to break it down into two vectors. And to be honest with you, it's easier than what we've been doing. Actually, you're going to find it amazingly easy. So here we go. Number 31. A vector W has a magnitude of 100 and points southeast. So I know it's going south and east, so I'm going to draw it like this. There we go. That's south and that's east. And resolve the vector into easterly and southerly components. So they want us to break this vector down into a vector going this direction and a vector going this direction, easterly and southerly. Now we know the length of this line is 100, okay? And you got to remember, if we went exactly southeast, that would be a 45-degree angle because we didn't go south and we didn't go east. We went right in the middle, southeast. So I know this is 45 degrees, okay? Now think about this for a second. If we're going to draw our parallelogram and then find this length here, I'll call it y, and find this length here, I'll call it x, this vector here, and this vector here. I mean, I've got right triangles, guys. It's really, really pretty simple. I mean, in fact, if I'm trying to find this length right here, isn't this length right here the same thing as this length over here? So really, I'm going to try to very quickly cut this triangle out. This is x, this is 45 degrees, this is 90 because we're dealing with south and east, and this is the length of 100, and this is y right here, so this is also y right here. Students, do you not see how easy it is to break down this vector into two components? It's a right triangle. We're just going to say the sine of 45 degrees equals opposite over hypotenuse. And then we're going to say the cosine of 45 degrees equals adjacent over hypotenuse. Multiply both sides by 100. So I have 100 sine 45 equals y. And if you type that into your calculator, you will come up with, I'm looking at my notes now, you're going to come up with 70.7. So 70.7. And then multiply both sides by 100 over here. 100 cosine 45 degrees equals x. Type that into your calculator and you will get the exact same thing. 70.7 equals x. Let's see if they ask us to do anything else. They don't. So the answer would be south 70.7 and east 70.7. So there you go. You took a vector that had a magnitude of 100 and you broke it down into these two vectors right here. This vector and this vector. Let's try another one, number 33. Number 33 says an airplane takes off at a speed s of 225 miles an hour at an angle of 17 degrees with the horizontal. Resolve the vector s in two components. Okay, no big deal. So here comes the airplane. Here's the ground. And the airplane takes off. And when it takes off with an angle of 17 degrees. So there we go. 17 degrees. And it says the speed of the vector of the plane is 225. 225. And then it says resolve the vector into components. So when it says components, all they want you to do is find this length right here. Let me change colors. They want this vector here and this vector here going straight up, and that's it. Now look, this vector right here going straight up is the exact same vector right here. I mean, it's the same height and everything. So look again, all that you have here is a right triangle. That's it. And we know the length of this line is 225. We know we have 17 degrees here, and we're trying to find x and y. So once again, I'm going to simply say sine of 17 degrees equals opposite over hypotenuse. Multiply both sides by 225. So 225 sine of 17 equals y. And then cosine of 17 degrees equals adjacent over hypotenuse. Multiply both sides by 225. And now both of these just become calculator problems. If you type in 225 times the sine of 17, let me look at my notes here. If I can find number 33, you're going to get 200, let's see if this y, you're going to get 65.8. 65.8. So that's this vector here going up, 65.8. And if you type in 225 times cosine of 17, you will get 215.2. 215.2. So this vector right here is 215.2. Let me grab a quick drink of water. So if this length right here is 65.8, then this one right here is 65.8. So look what you did. You took this vector right here and you broke it up into two components, this component and that component. You could go backwards. You could take these two, and if you were adding them together, you would get 225 if you were doing vector addition. Okay, let's take a look at number 35. Number 35 says, a luggage wagon is being pulled with a vector force of V, which has a magnitude of 780 pounds at an angle of elevation of 60 degrees. Resolve the vector V into components. Well, I mean, it's really pretty simple, guys. We have an angle of elevation of 65 degrees, or is it 60 degrees? 60 degrees. So an angle of elevation of 60 degrees, like this. And then this vector going up here has a force of, or a magnitude of 780. And it says resolve that vector. So I'm going to resolve that vector into this one here and this one here. Okay, now remember, probably the best thing to do is just to pick up this line and just move it over here, move this vector over here, and then I've got a right triangle. Okay, and that's pretty simple to do. So now I'm going to find this length here. We'll call it x, and we'll call this y. And you're breaking this up. You're breaking up the vector 780 into two vectors. So it's going to be the exact same thing again. It's really getting redundant. Sine of 60 degrees equals opposite over 780. Multiply both sides by 780. And 780 sine of 60 equals, let me take a look here, that would be y, and that would be 675.5. So 675.5. And then if we take the cosine of 60, it would equal adjacent over hypotenuse, multiply both sides by 780. Type that into your calculator and you will get 390. And of course I'm pretty sure these are rounded, but 390. So there we go. So this length right here would be 390. And this one here would be 675.5. Okay, so there we go. Moving on to number 37. Not too bad. All right, number 37. Same thing again, guys. Here we go. Redundant. An airplane is flying at 200 kilometers per hour in a direction of 305. Find the westerly and northerly components of its velocity. Okay, first of all, I guess this will be a little more difficult, but not that bad. I mean, here's your coordinate plane, and it says that the airplane is traveling at a direction of 305 degrees. So if I start here and go to here, that's 270. So I've got to rotate 35 more degrees. Okay, there we go. Now the force of that is 200, so I'm going to go ahead and label that line right there, 200. And then it says, listen carefully, it says find the westerly and northerly components of its vector. So if we're going this direction here, then we're going to find the westerly and the northerly components. So I'll put an arrow there and an arrow there. We're going to find the westerly component and then the northerly component. So if we traveled around 270 and we're going to 305, then we know this has to be 35 degrees in here. And so trying to call this y, we'll call this x. Trying to work quickly, we're just simply going to say the sine of 35 degrees equals opposite over 200. If you multiply both sides by 200, you'll get 200 sine 35 degrees equals y. And then if you type that into your calculator, I'm looking for my notes here, you're going to get 115. So 115 equals y, so that's the magnitude of this vector here going up northerly. And now let's find the value of x. So we're going to say the cosine of 35 degrees equals adjacent over hypotenuse. Multiply both sides by 200. And then type that into your calculator, and you will get 164. 164. So you would say north 115, and, excuse me for yelling again, west 164. Okay, so there we go. That's it. You took this vector right here, 200, and you broke it down into components. So really good job. All right, let's take a look at 39 and 41, and we're finished. Now in number 39, well, let's read it first of all. A block weighing 100 pounds rests on a 25-degree incline. Find the magnitude of the components of the block's weight perpendicular and parallel to the incline. Now, to be honest with you, the next problem we're going to do, number 41, if you want to flip over one page and look at it, no pictures given. That's going to be a tough one. I will help you with that, okay? But 39 is not too bad. I mean, they tell you already, by looking at the picture here, that the length of this line is 100. The magnitude or the force or the result, whatever, is 100. And all they want, and they tell you this angle right here is 25 degrees. 25 degrees. And all they want you to do, if you'll read the directions, is they want you to simply break it down into components, parallel and perpendicular to the incline. So all we're doing is finding this vector here and this vector here. That's all that we're doing. So it's really not too bad. So if I took my this thing I'm going to trace, if I traced, let's see, this triangle right here. If I traced that triangle right there and pulled it out and then made it bigger so we can use it a little easier, I would have a right angle right here, because I know this is vertical and horizontal, and I know this angle right here is 25 degrees, so I can put 25 degrees right here. I know the length of this line right here is 100, and I know I'm looking for A and B. Well, it's really becoming almost humorous. It's the exact same thing. I would say the sine of 25 degrees equals opposite over 100. Multiply both sides by 100. So 100 sine of 25 degrees equals B. Now, I'm going to look at my notes here. That would be, if I've done this correctly, 42.5. So 42.5 would be your B value. And then the cosine of 25 degrees equals adjacent over hypotenuse. Multiply both sides by 100. 100 cosine of 25 equals A. And then, if you type that into your calculator, you should get 90.6 for A. So there you go. You took this vector right here and you broke it up into two components. This component right here and this component right here. B is 425.400 or 42.5, excuse me, and A is 90.6. Okay, pretty good. Last problem and we're done, so not too bad. And then I'll give you the review sheet, which is right here. It's normal. It's 30 problems. It's nothing abnormal. I would do 15 today if at all possible, and I would do like 5 on Friday and 5 on Saturday, or so, or 5 on Friday and 5 on Saturday, or something like that. Break it down to 5 on Sunday, something like that. But anyways, so let's take a look now at number 41. Okay, let's read the problem carefully. An 80-pound block of ice rests on a 37-degree incline. So, here's my 37-degree incline right here. I like to make it nice and big so we have plenty of room to work. So there's my incline, okay? Now, a block of ice rests on it, so I'm going to go ahead and put my block of ice right here. There's my block of ice, okay? And, let's see, what force parallel to the incline is necessary in order to keep the ice from sliding down? Now, with the weight, and we're going to call the weight the force, okay? Just like in the previous problem, right here, if I can erase this quickly, we had notice carefully, we had a weight of, if you'll read 39, it was a weight of 100 pounds. And notice it's not, the weight of this box here, notice how it's sitting on an incline, is not going to be straight down or straight forward. It's going to be going down kind of at an angle. In fact, it's no coincidence that this 25 degrees right here is the same angle that's right here, 25 degrees. That will always be true. Okay, so we're going to use that in just a second. But what I'm saying is notice if this block here in number 39 weighed 100 pounds, notice how we draw it diagonal because the weight's not going straight down or straight over. Okay, now, so with that in mind, let's come over here and let's go ahead and draw this vector here. And this is the one, just like in the previous problem. This is the one here going straight down. That's going to be, let's look at the word problem, 80 pounds. So this line here has a force or a resultant or a magnitude of 80. Okay, and then we're saying that's the force. Let's break this down into components. So we have a component going this way and then one going this way here, forming some really nice right triangles. Okay, so it looks like this. Make it really big. We have a component coming that way, a vector coming that way, and then this coming off right here, and this is 80 right here. Now, remember how this angle here is 37 degrees? So we can also call this angle right here 37 degrees, and that's totally normal. Okay, totally. So 37. So, I mean, if I now just simply bring this line down, the question is this. If you'll read the problem, it says find the force necessary. So remember, we can take this force right here. Now watch this carefully. We can take this force of 80 and we can break it down into two components. One going this way and one going this way. Alright? So, it says find the force parallel to the incline. Well, the force parallel, here's the incline. The force parallel to the incline would be this force right here. So I'm trying to find this length right here. Well, here's your force, your vector coming down. If I draw a line straight up, I'm going to have a right angle here. Okay? And now think about it. If this is 37 degrees right here, then I know this angle right here has to be 53, because together these two angles are a right angle. So 53 plus 37 would be 90. So here's my right triangle right here. Here's my right triangle. It goes over and down, and that's a really bad job. Let's try it again. It goes over, down, and then up. So there's your right triangle. And I know that I have a right angle here, and this is a length of 80, and this is 53 degrees right here, and I'm trying to find this line right here. So based on 53, I'm dealing with adjacent and hypotenuse. So I would simply say the cosine of 53 degrees equals adjacent over hypotenuse. Multiply both sides by 80. 80 cosine of 53 degrees equals x. And if you type that into your calculator correctly, you'll come up with 48.1. 48.1 is the force that you need, and we're going to say pounds because the 80 they gave to us was in pounds. So 48.1 pounds is the magnitude of this vector right here. And so that's the parallel force needed to hold that ice block in place so it won't slide down the ramp. Okay? Now, let's take a look at this. Here's the review sheet. There it is. Copy it down. Work on it. You say, well, Mr. Earhart, you're going to have a video for us on Friday going over this review sheet, correct? Yes, I will. It might even be 2 videos. I never really know until I get into it. If I start getting tired and my voice starts giving out, then I'll stop and I'll make another video. So you'll always know when you look at your videos, you'll see if it says part 1, part 2, part 3, you'll know then how many parts I divide this review sheet up into. But that'll be ready for you on Friday, and you do not have to do this review sheet. Do you understand? You do not have to, but it does give you 5 bonus points on your test if you've tried every single problem before you walk in the door Monday. So for the test, study the word problems and then do all of these problems here. If you can do all of them well without your notes and without your book, then you should be ready for your test. Have a good rest of the day, and I will talk to you guys on Friday.